Thank you, everybody, and thank you for the privilege to present today. There's a rather esteemed bunch of presenters, and obviously for the celebration of Bruce's enormous contribution. What I'm talking about today is something I was privileged to collaborate with Bruce and Colin and Jim, and with regarding compressive strength tests and expecting low breaks. So I'll just quickly go over this. So basic introduction, it's normal, the question comes up is it normal for a strength test to be less than F prime C, and how often? Per the ACI 318.26.12.3.1, it states that it's acceptable if the average of 3 consecutive tests equal or exceeds F prime C, and then each individual test is not less than 500 psi, or if it's the strength is greater than 5,000 psi if it's within 10%. Those are the rules, but like the expectation in the field is like if there's a low break, the alarm bells are they're going, they're ringing, the red lights are blinking, and we're all in a crisis mode, and the owner and et cetera, is the work is suspect and needs to be ripped out. And that's not true. And this paper that we collaborated with is kind of trying to point this out. So in terms of designing a mix, the ready mix partner, they're targeting what an average strength here, and that's basically going to be defined as basically the target F prime C plus 1.34 standard deviations. And with this approach, 90% of all the tests should be exceeding this F prime C, but that also means that there's 10% that would be less. So therefore, you would expect to get low breaks. And so for this table, as Colin presented previously, based upon a statistical approach, you would absolutely expect to get some tests through the course of your project that would be low. So for instance, you got these different types of jobs, like a smaller job, 1,000 cubic yards, a larger job, 100,000 cubic yards, and the frequency or the number of tests. And then, so for instance, for the small job, and say you're doing 1 per 150 cubic yard, you're going to get definitely one break. Again, assuming that the mix was designed using statistical probable methods. And if you got a big job, 100,000 yards, you're going to get 67 low breaks. So this causes headaches, and no one wants headaches. The ready mix suppliers, and Colin can speak to this, are some of the most screamed at people in the construction industry. There's a lot of things that they're asked, and and if the things aren't going right, there's lots of phone calls going back and forth. So quite often, and pretty much almost standard practice, the ready mix suppliers are over designing their mixes, and to avoid the screaming phone calls. There are also, obviously, there's other parameters that they could be driving the mix design, in particular issues that are important to the contractor in terms of set time and high early strength. But a lot of it is also just to avoid headaches with testing, and avoid basically being the victim of another party testing their material and them suffering the consequences of that. So for instance, there's real costs, and there's sustainability parts to this. So for instance, the ready mix supplier is looking to, again, avoid headaches, and they throw in an extra 50 pounds of cement per yard in the pursuit to just avoid problems. And if we just say, hypothetically, this is going to add an extra $15 per yard, so for a 100,000 cubic yard project, that's like $1.5 million. It's not small money. So, but again, this is in the basically managing expectations and trying to avoid the headaches. That there's extra dollars being put in that arguably shouldn't be there. And there's also the sustainability part of it. That extra cement, though, can also cause other issues that people are dealing with that could potentially be increased, such as increased shrinkage and potential cracking of the members because of this extra Portland cement, or even mass concrete issues in terms of extra reactive material elevating temperatures. So no, there's issues that are unintended consequences that come out of this. And then just furthering the point, the mixes Obviously they're shooting for a target, but the variability is coming in from the testing. And so again, if you got greater variability, you end up with this red bell curve here. So there's basically this over design is resulting in additional cement requirements, and there's cost and there's sustainability consequences. So testing troubles. There's a lot. There's a big long list here. But fundamentally, it all really boils down to not strictly following the ASTM procedures. So there's a whole bunch of stuff that goes on from basically collecting the sample, to basically filling and basically filling the molds, ensuring that you got proper consolidation, ensuring that they're properly protected from the elements, and then there's the whole issue of handling and making sure that they're protecting that in a protected condition for that first day. I think it get picked up. They're being properly cured in the lab, and then they're properly prepared for testing in terms of grinding or capping, and then properly performing the test on calibrated equipment, et cetera. So again, there's a large number of things here, and we're all familiar with them. But all this stuff together, can result in increased variability, and then we all deal with that. So here's an example. So you have a low break. So this is a project that we were involved not too long ago, and we ended up getting a report for this, and we end up with this language here, fail to meet reference values. So this testing agency, who is paid by the owner, issues this report, and basically has this language out there, and it immediately causes alarm. And so I think perception and labeling matter, and the people who are in receipt of this report and are passing this report around and discussing it are not necessarily the engineer record or the informed contractor or the ready mix partner. So there's a wider alarm that arguably was excessive. So there's the language is important. It's also important to note that it's not the testing agency's role to say that this particular mix and placement was rejected. It's just their role is to obviously perform their test to the ASTM standards and report the results. Some testing agencies provide 7-day and 14-day breaks, and this was the case for here. So we had 5 cylinders or 5 specimens collected. We broke one at 7 days, we broke one at 14 days, and then we broke the balance at 28 days. Now the 7 and 14, that's interesting stuff. We had a 7,000 target, and we're 5380 and 5570 at 7 and 14 days respectively. But we don't have any reserve cylinders afterwards, so we're now left in a pickle. It would have been arguably a more useful information to maybe cast additional cylinders, or potentially not break the 7 and 14 for this example. So we would have had that additional data. So again, having those hold cast cylinders are really, really important when you're in this discussion about do we have an issue, do we have a problem? And this issue here with reported low breaks, I can say personally from Chicago that this is becoming a more common occurrence. It's not typical, but the frequency is definitely increasing. And I think that there's definitely a link between the increased use of SEMs and the Type 1L cement. So investigating test reports or test results, low strength. So basically we all sometimes feel like this guy here, and we're what do we do now? So 318 and 301 give requirements for the engineer and the team to follow in terms of investigating low test strength reports. And the language in ACI documents, they use this term judgment, and that's critical, and that should be in the minds of the parties that are investigating this. And so allowing basically the acquisition of information to be utilized to help shape decision making, and letting the engineer record basically use his or her experience or judgment to help assess whether the actual placed concrete is fit for purpose, or some other remedial measure might be required. And there's additional examining the testing, so looking at the test reports, looking at any kind of information you can find out, in terms of like literally as simple as like, the trucks, the frequency trucks, like, the temperature, all that kind of stuff, like to see what kind of information can be gathered. Looking ideally if getting data from the hold or reserve cylinders, which would have been taken at the same time from the same batch, same truck, and would have been really helpful to like understand like what are the results we're looking at, and then non-destructive testing for like a relative assessment, and then like last but not least, but this is the worst case scenario, the coring. So engineering judgment. This is like, again, like I said, it is an important concept, and it's a concept that ACI strongly advocates. The word judgment appears frequently throughout the document, 16 times in 318. And one of the more important places in that document where it uses the term judgment is in the opening chapter, where it says the code and commentary cannot replace sound engineering knowledge, experience, and judgment. So again, the document empowers engineers to basically use their experience and use the ability to gather information to form a judgment. And with this, this triangle here kind of shows you the sort of things that the engineer should be thinking about in terms of safety, functionality, and cost. As they formulate an opinion and say whether we have an issue or some sort of remediation or mitigating measures need to be taken. It is, again, the role of the engineer record to allow acceptance of F'(c) lower than specified. If they, by their review of their analysis, find that a lower value based upon the reported test values, it's absolutely within their role as EOR to accept that material. And then there's also just basic knowledge, like knowing that like the report represents the test that was done by a third party, and it was at a point in time, say 28 days. Arguably the concrete is absolutely gaining strength after 28 days, and those individual reserve cylinders, if they're broken at 56 and 90 days, even though they're individual cylinders, by all means they would be representative and it would be a basis for argument for acceptance. And a low F'(c) test does not necessarily mean that you have low strength concrete in situ. So again, just you need to be able to use your deductive powers to make sure that understand what's being reported to you, and use your engineering judgment to make the best decision. Use your test cylinders wisely. So if you have you're fortunate enough to have them, use them. The owner has paid to the testing service to basically cast and to cure and to store these, and they're paying good money for this. And so it would be, as the engineer, to basically not use this resource that the owner has paid money for, arguably is basically a disservice. So this is a resource the engineer should definitely lean upon it. Even though you might have reserve cylinders and be breaking only individual like one or two, and arguably it's not, again, following the exact written word of the code in terms of 3 samples. This is where the engineering judgment comes in and saying well, these were batched in the same set. These are just at a later date. Owners, again, like I said, they pay for them, so we should be using them. And then also just using the cylinders and gathering additional information. So sometimes just weighing the cylinders would give some useful information in terms of in terms of the sample itself. Is it low density? Was it is there a consolidation issue? And is that then throwing up the low breaks? Non-testing or non-destructive testing options. So here's some really simple 3 methods that are a good useful tool to give you a sort of a qualitative feel for what's going on, and again, they do not replace a cylinder, but they would give you a feel for what's going on in situ. So you got the Windsor probe here in the top right, you got your Swiss hammer in the bottom right, and then you've got the pull-out test here in the bottom middle. These, if they're properly calibrated, they produce or are more useful information. If they're not completely calibrated, they still provide information that could be useful in a conversation in determining is this material placed, is it acceptable, or we have to do something? And then in last resort or in extreme cases, and the word extreme is actually in the code, it's highlighted there in the bottom, we can do some core testing. So it is arguably should be the last resort. It should be performed after exhausting all other options, and is often unnecessary expense, and quite often can lead into a whole spiral of confused conversations and hand-wringing and an undue alarm. So basically, I guess myself and my fellow authors were kind of advocating like caution in this this approach. Again, like per the code, they say like the concrete as the concrete that is extracted by these cores is deemed to be structurally adequate if 1 and 2 are satisfied. So the average of 3 cores is equal to at least 85% of F prime C, and then no single core is less than 75%. Just from my experience and where we've gone down this path, cores are lower, and generally speaking, they just by the process of sampling and the process of doing the tests and whatnot, this statement here of searching for that 85% is very, very true. So again, sometimes it is found to be a quick slam dunk, and other times, and quite often other times, it can be just cause more confusion and more hand-wringing by the parties. So I guess my comment to all is basically use with caution. Beware of core removal and testing that is not in accordance with the ASTM C42. A lot of the low values that come out of coring arguably come out of not strictly following the ASTM procedures. So the 318, 261261C considers the engineer as a specifier of the test. This is an important distinction, as the ASTM C42 recognizes that the individual is permitted to alter default requirements and is responsible for analysis review. So things become, again, a lot of open for interpretation discussion. So again, it can end up causing more discussion and more hand-wringing as opposed to being a quick resolution to an issue. And then here's kind of a further point about this. Very important facts that are often not understood by persons writing purchase orders, evaluating strength tests, or evaluating results of in-place core concrete strength specimens is you've got category A and B. So A, the ready mix producer is responsible for the quality of the concrete that's delivered to the job site when the concrete is sampled according to ASTM C172. Strength specimens are cast and cured as per ASTM C31. Compressive strength specimens are tested per ASTM C39. Flexural strength specimens are tested per C78, and the testing lab and the technicians are all certified. So there's a whole bunch of ASTMs there, and qualified people following strict procedures. The in-place concrete strength from core testing, generally test specimens are obtained when there's doubt about the in-place concrete, either due to low strength tests or possibly signs of distress. And these test results are not the same as outlined as in A, and they should not be confused. So the stringent control of the sampling and the testing is not as rigorous as it is in A. And claims, credits, and damages, oh my. So the 28-day cylinder strength should be at or above specified strength, or the owner is not getting what they paid for. This is false. If the F prime C were the minimum, then the code would never accept something less than F prime C, and as it clearly states in the code. Furthermore, below strength concrete is may be sufficient and does not represent a loss or damage to the client. This perception in the public or in the client's idea is like, well, I got something less than what I paid for, I got a damage, you owe me money, but it doesn't go the other way. It's like, well, we're the concrete contractor. We basically overshot all the mixes by 25%. I want 25% more money. It doesn't work that way. So the owner is benefiting, with a properly designed mix that is optimized with the possibility of reduced cement. There's a benefit from concrete cost, and there's a project improve sustainability. So there's a benefit that the owner is getting by allowing a more optimized targeted mix design. And providing a financial credit for this issue would indeed be granting a windfall, an unfair windfall to the owner. So it wouldn't be appropriate. So. And then here's from our publication from February last year. And so this is, Colin hinted at this, and this is sort of a silly anecdote here at working with Bruce, which I really have enjoyed for the last, 10 or 12 years with my involvement in ACI. So it's the esteemed authors are Jim Klinger, Colin Lobo, myself, and Bruce. And we're gathering up this document, and we're getting ready to submit. And I was a bit tardy about putting my headshot into the submitting it. So they were looking for a picture of an Irish guy. So Shane McGowan of the Pogues is a good, a good substitute. So that was internal humor. But then, unbeknownst to me, that Bruce just submitted it to ACI. And then it gets better still. So then after it got accepted by ACI, he sent it back to me, say, hey, congrats, our article got published. And he put down here, the PDF, and he basically put my name as Hold My Drink. So I didn't catch that. So then I passed it on to my colleagues at work. So thank you, Bruce. But it's been a great privilege and most enjoyable working with you all these years, and really appreciate all your contributions. So.